In this module, we will be discussing the few more concepts relating to the construction of frequency distributions. In the previous table, as we said, that in two classes, there is always a gap of 1 unit. If by any chance for the continuous variable, a value falls in between these values, the question arises that what should be done? In such situations, we will construct the class boundaries, where class boundaries are used to separate the classes, and most importantly, when we are drawing graphs for our data, so that there are no gaps in the class limits in the frequency distribution. Class boundaries should have one additional decimal place and end in a 5. Moreover, the lower class boundary that is denoted by LCB will round to lower class limit, and the upper class boundary will round to the next class. Another way of thinking this is that draw the boundaries halfway between the consecutive classes. Let's look at the data. We are using the same data that's given by Gold et al. Regarding the high ages of 189 individuals. For this data, we already constructed the classes and the frequencies. When we are to construct the class boundaries from it, we firstly note down the difference between the upper class boundary, upper class limit of the first class and lower class limit of the second class, which turn out to be 40 minus 39, it is 1. Since we want to go exactly the halfway through it, we will divide this difference, let's call it D, and this as divided difference 1 by 2, which is 0.5. Now to construct the class boundaries, we will subtract this divided difference from each lower class limit, and we will add this divided difference into each upper class limit. Hence, 30 minus 0.5 is 29.5, and 39 plus 0.5 is 39.5. And same way, we will subtract 0.5 from each lower class limit and add 0.5 to each upper class limit. In this case, if by any chance a value falls at 39.5, it goes to the second class. Because the class limits are both inclusive, lower class limits and upper class limits. If any value falls on border, it clearly identifies a value into each of these classes. But for the class boundaries, if value falls on the border, it always goes into the next class. Like if by any chance a value turned out to be 79.5, then 79.5 is in the two classes. Then we classify 79.5 into the second class. Moreover, we can also construct the class marks, which are also called as the midpoints. Class marks are obtained by obtaining the center. To obtain the mid of it, we can either subtract these class boundaries and then divide them by 2. We will get 34.5. And the same way for all. Since we already know that the height of the class interval, that is the class width, is h, which is equals to 10 in this case. For the class marks, for each value, it is equals to h, which is 10 points, 10, and 10. We can also construct the class boundaries for ungrouped frequency distributions. I'm taking this example from the previous module where we constructed this ungrouped frequency distribution, where we have the number of surgeries Since number of surgeries is our variable, I am denoting it by x. We constructed the relative frequencies out of it. To construct the class boundaries, we will identify what's h. H is the gap between these values, and over here it is 1, 1, 1 for each. For the class boundaries, the first class h by 2 in this case is 1 by 2, which is 0.5. We will subtract 0.5 from each value in each class and then add as well. Whereas the first class boundary for the first class turn out to be minus 0.5 and the upper class boundary will be 0.5. For the second class it is 0.5 and 1.5. 1.5 to 2.5. 3.5, and it goes on. These are the class boundaries for the ungrouped frequency distributions. We do need class boundaries when we are constructing different graphs for these variables. Cumulative frequency distribution shows the number of observations less than or equal to the specific value. Cumulative frequency distribution are constructed when we add another column to the frequency distribution. That's called cumulative frequencies. These are easy to determine from the frequency distribution, where we simply add the number of observations for each class with the previous classes. If we want to understand this concept more clearly, then we need to know that cumulative adds up the previous things. So in the cumulative frequency distribution, we have this grouped frequency distribution. If we want to construct the cumulative frequency distribution, we need to add the frequencies. Whereas for the first class, there is nothing behind 11. So the first cumulative frequency will stay the same as it's in the frequency. But for the second class, we will add 46 and 11, which is equals to 57. And same is the case for the rest of the classes, where we keep adding all the previous observations. All the previous frequencies are added, and the last frequency, cumulative frequency, which should be equals to sum f, since it's accumulating every single observation. We can also construct relative cumulative frequencies, where we keep adding the relative frequencies. The last value in the relative cumulative frequency is the sum of the relative frequency. They should be the same. Cumulative frequencies can also be called as running totals of frequencies. Cumulative frequencies, frequency distributions have a very important property that they are non-decreasing. And lastly, cumulative frequency curve is known as ogive.